Is that
recording here probably serious.
my slides are visible to you?
Sir, your slides are visible, sir. Yes, sir, your slides are visible.
Thank you so much for the full introduction of the thing. First of all, I want to thank the organizing committee for inviting me for this session. So, and also I want to thank AICT and Atal for conducting this kind of faculty development program. So today's session, I am going to talk more about the additive manufacturing process, particularly related to healthcare application, and what are the advanced materials currently they are using for advanced additive manufacturing process, and how to make the models, particularly in medical application. These are the things which I am going to cover into this session. Uh, so outline of the presentation is introduction about additive manufacturing. Before going into the advanced application, I want to discuss with you some basics of additive manufacturing. Then I will get into healthcare application. What are the areas you can do the research, because most of the faculties are related to mechanical material science, I think so. So how these kind of people have fit into healthcare application. So these and all I can cover in this presentation. Then what are the different type of additive manufacturing processes, which is closely related to healthcare application. Then what are the materials and advanced materials which are used in additive manufacturing process nowadays. Then applications such as tissue engineering and regeneration, and then customized implants and prosthetics, then drug delivery application, then research scopes in additive manufacturing. These are the area which I am going to cover in this session. Okay. So coming to additive manufacturing process, before going into additive manufacturing process, people should know about what is manufacturing process. So manufacturing is nothing but when you are going to develop some components or a product with the help of machine, men or tool, we call it as manufacturing. When you are making a component such as when you are making a water bottle, this is one of the product. So you these kind of products which you are developing, which is called as manufacturing process. So the manufacturing process can be classified into two types. One is called conventional manufacturing process. In conventional manufacturing process, the process in which you are eliminating the material, which all comes under the subtractive manufacturing process, which is called conventional manufacturing process. For example, lathe, such as drilling, milling, everything comes under subtractive manufacturing process. Then coming to additive manufacturing process, this is the advanced manufacturing process. In this process, you can fabricate the component by a layer by layer. So, or you are developing a component in a layer by layer. We call it as additive manufacturing process. What is the need of additive manufacturing process when you are going for compared to the subtractive manufacturing process? When you are fabricating a complex component, when you are doing in subtractive manufacturing process, it takes a lot of time. The complexity of the product leads lot of manpower with the well-skilled laborers. But in case of additive manufacturing process, the designer will constrain all the on the design, and they will fix all the models. This is the main advantages of additive manufacturing process when compared to subtractive manufacturing process. And also the main advantages in additive manufacturing is you don't have a high energy input like that. You don't need to spend a lot of money to build the system. So these are some of the advantages of additive manufacturing process when compared to subtractive manufacturing process. So people call it as 3D printing, but the thing is, it is not a 3D printing. It's an additive manufacturing process. There are a lot of printings are available. The people should know what is printing. Printing is nothing but when you are depositing a material on the substrate, which is called as printing. So substrate which is not nothing but a print bed, we call it as substrate. So there are a lot of printings are there. First one is 1D printing. When you are making a component in one dimensional direction, 1D, which is nothing but one dimension or one direction, we call it as 1D printing. When you are making a line in a paper, we call it as 1D. When you are going in x-axis, no, that is called 1D printing. When you are going for two-dimensional printing, if you are writing something like any alphabets in both the axes, x and y, we call it as 2D printing. So when you are printing something, when you are photocopying something from the photocopy machine, we call it as 2D printing. The Xerox copy, it is called as 2D printing. Coming to 3D printing. 3D printing, which is nothing but when you are giving a third dimension, which is the thickness direction, when you are making a component in third dimension, which is called third dimension, which is called X, Y, Z. When you are making the component in a Z direction, we call it as 3-dimensional printing. In most of the colleges, they are having 3D printer. So people call it as additive manufacturing as a 3D printer. And also in almost all the engineering colleges, they are having a FFF based, FDM based printer, which is called as fused deposition modeling printer. So they are having 3-axis printer, normal CNC machine kind of stuff. So people call it as 3D printing, but it is not a 3D printing. In general, the fourth industrial revolution makes the 3D printing, which is called additive manufacturing, boomed. But the fifth industrial revolution, 5D printing has evolved a lot. So what is meant by 5D printing? Before going to 5D printing, I will tell you about 4D printing. So anyone know about 4D printing? The next axis, which is called as fourth dimension, which is called as rotational axis. When you are giving the rotational axis to the extrusion head, which is called as 4-dimensional 4D printing. So when you have a complex part, you don't want to print the support along with the print part. So you can use the 4D printing. The complex part without support, if you have a beam kind of component, you can use 4D printing. Then what is called 5D printing? So already I have told that in 4D printing, you have given the rotational axis to the extrusion head, which is called as 4D printing. So additionally, you are giving the fifth axis, which is the rotational axis given to the print bed. We call it as 5D printing. So you can rotate both the extrusion head as well as the print bed. So where this kind of 5D printing should be work. So most probably if you are making a propulsion blade and also turbine blades, the turbine blades which have a complex shapes, if you are making with these kind of models with some kind of applications like aerojet application, aerospace application, this 4D printing as well as 5D printing has a huge potential scope. And also if you are fabricating a component in construction industries, if you are fabricating house kind of stuff, nowadays they are using KUKA robot. They are using in KUKA robot, they are fixing the extrusion head with the extrusion head as in the head edges, and they are using 4D printing for construction building. So these are the examples of printing. Okay. So history of 3D printing. So everyone knows that 3D printing was evolved now in the 2010, not like that. In earlier days itself, the 3D printing was evolved. In the 19th century itself, it was evolved. But the thing is, initially they have used only for the prototype applications. But the problem is, initially they have developing a prototype using 3D printing, and they have used mostly in various R&D sector only they have used 3D printing. For the most of the applications for prototype making. But later 2010, based on the fourth industrial revolution, it was very much evolved about material development, technological development. Nowadays, I have already told that all the colleges they are having FFF based, FDM based printer. In FFF based printer itself, one of the company which is called Bamboo Lab. They are the pioneer. Last 4 years, they have evolved a lot. They are nowadays you don't need anything. Don't need a STL file. If you have a solid part file itself, if you load the file and you can print directly using the Bamboo Lab Studio. These are the advantages. They are evolving a lot. For the last 5 years, there are a lot of new invention related to additive manufacturing process and also materials development. Nowadays, there are a lot of materials like they are developing our own organ itself nowadays. These are a combination of hydrogels, our cells, everything they are mixing together and they are fabricating our own organ itself. So these are the advantages. So why there is a need of additive manufacturing in healthcare application? Why I am much more stressed towards healthcare application? Because if you are, I will tell all the points with some kind of examples. So if you are making one implant, if you are making one bone plate, okay. So every human hand is different than other human. So if you normally Stryker is one of the best company for making implants. Normally the implant was manufactured in a mass production orientation. Like if you have a age like 20 to 30, the bone size will be like that. It is in the range like that. They are fabricating the bone plates with hand. The bone plate will be like this, leg like this, head like this, like that. They are fabricating the bone plates. But the problem during these kind of bone plates is when you are fixing during the surgery process, when you are fixing these kind of blown plates, it has some kind of deviation. This kind of deviation make stress to the surgical the people who are doing surgery. So this will make some kind of discomfort during this kind of surgery process. So this can be avoided when you are additive manufacturing, when you are using additive manufacturing, which is rapid prototyping process. The medical professional can easily develop the component. Just they will scan your fractured bone. Like if you have a bone fracture in your hand, they will scan your hand. Then after scanning, they will have the CT data. After getting the CT data, there are some kind of pre-processing software. They are feeding the software into this kind of software, and they are fabricating your own implant. I will discuss these things in elaborately in the upcoming slides. So these are some of the applications. Then mass production orientation. In conventional manufacturing,
Hello.
mostly they are fabricating in a.
Sorry to introduce you. I
Yes,
think
yes,
your
yes.
slide is not changed. It's an initial slide. It's a slide only changed.
Is it visible?
You are not enabled the presentation mode. Sir.
1 minute. 1 minute. You is it visible?
Yes, sir. Now it's visible. Sir.
Okay. So coming to yes, coming to the types of additive manufacturing process. So mostly I think everyone knows about some kind of various types of additive manufacturing. I am not going to in depth about the various kind of additive manufacturing process. I will just tell you what are the types of additive manufacturing process, which is closely related to types of material, types of form, and types of energy, because these are the main component which they are classify the additive manufacturing process effectively. So the first one, which is called as materials. So normally most of the people will work on polymers, metals, and ceramics. These are the main materials people will work. So based upon the material and type and its form, the additive manufacturing process can be classified. So then the form would be liquid form, powder form, wire form. These are the main forms of material. Then the energy should be heat or UV or a binders, some kind of additives, or arc, which is energy, which is in the form of heat, then plasma, then laser. These are the type of energy which we are using. So combining all the things, and I will tell you the process. So the first one, which is the material extrusion process. The material extrusion process, which is nothing but FDM process. In this process, they are using two different types of material. One is called filament, another one is called pellets. So in the material, another one is called paste. So the paste method, we call it as fused, not a fused one. This is a direct ink writing method, which is called as paste method. Okay. So first one, which is called material extrusion method. In this method, they will use the material in the form of wire, and they will melt using the heat source, and they will deposit on the workbench, which is called as a print bed, which is called as material extrusion method. Then second one is the wet photopolymerization. In this method, they will use the liquid ink, which is called as a photopolymer. They will use UV source, which is called as SLA. When they are using binder, which is binder jetting. When they are using UV source with a different kind of light, which is the UV source, which is called as material jetting, which is called as polyjet technology. Okay, so the next one is arc. When they are using wire, which is particularly in metal application, which is called as wire arc additive manufacturing process. When they are using powder forms, when they are using powder form in all kind of application like polymers, metals, as well as ceramics. When they are using powder form in ceramics, they are called as they will use powder bed fusion method. When they are using powder in metal, they are also using DMLS, powder bed fusion method, as well as dead, which is method, direct energy deposition method. Then polymers, they are using SLS. This is selective laser sintering method. They are using nylon based material for fabricating SLS based method. Okay. So mostly I will cover in this session, which is related to polymer, because I am basically I am a polymer. My research is related to polymer background, so I will cover mostly related to polymer materials. So everyone know about type of polymers. So one is thermoplastic, another one is thermoset plastic. Thermoplastics, which are mostly used for fabricating heat-based application like material extrusion kind of application, they use thermoplastic. Thermoset, which is mostly people will know about epoxy, vinyl ester, polyester. These are the most used thermoset polymer. But here I will here most of the additive manufacturing process they will use epoxy. Epoxy with different grades, UV curable epoxy as well as normal epoxy are available. Most of the UV curable epoxies are nowadays using for additive manufacturing process. So I am much more concentrated towards thermoplastic, because thermoplastic is easy to fabricate the component, and also the application perspective, thermoplastics which are having good application in biomedical application like PEEK as well as uh, some other materials. I will explain those materials in future upcoming slides. So PEEK is one of the material which are mostly used for the implant application, because it has a good thermal resistant as well as biologically inert. So it will be very good useful for fabricating the implant kind of applications. Okay. So I have already discussed about these kind of applications. For first one is material extrusion. First one I have already explained about fused filament fabrication. The next one is direct ink writing. The difference between triple F and direct ink writing is the material is extruded by using heat source. We call it as triple F method. The direct ink writing, the pneumatic control system, which is based on the pressure, the material has been deposited on the platform. After that, the curing is based upon the method of curing. If you want to cure the material, what material you are selecting. If you are making ceramic based clay, now you need to put it in the furnace for sintering purpose. When you are using some kind of biopolymers like carrageenan, some basic polymers, you need to put some cross linkers to cure the material. These are the difference between the triple F as well as direct ink writing method. Then coming to wet photopolymerization, which is nothing but a SLA method. In this method, the material can be deposited on the moving bed with the help of UV light source. You can print your material. This is the wet photopolymerization. Then powder bed fusion. Powder bed fusion is nothing but every time the material will be deposited on the respective dimension. Then the scanning system, which is the laser source, will be cross-link the material. Then the material will be pulled out from the print bed. Every time it will go on to and fro motion, the excessive material will go out and the new material will come up to the filling space. This is called powder bed fusion. In material jetting method, the UV light source will be used as a cross-linker. The difference between metal jetting and binder jetting is nothing but when you're using UV light source, we call it as material jetting. When you are using some kind of additional binders, each layer, when you are using some kind of binders, we call it as binder jetting. So this is the difference between material jetting and binder jetting. The material jetting, which are very much costlier, the patent rights for the material jetting will be owned by Stratasys. So these are one of the biggest company in 3D printing. So the last year, the material jetting patent rights was expired. So China entered into the market and they are developing their own machine. So most probably the low cost machine like triple F machine. So before entering the China into the triple F based FDM based machine fabrication, the normal FDM machine itself very costly. Once the China entered into the market and they are fabricating their own machine, the price was very less. Then everyone was using the triple F based printer. So now the people are mostly working on triple F based in research. People are nowadays they are using a lot of research activities related to triple F based printing. Similar to that, metal jetting also the machine will be some machines they have already put it in the market. In future, we will expect a lot of new machines also. So coming to process of 3D printing, everyone knows about 3D printing steps. So you have these are the simplest steps which you are when you are going to follow the 3D printing process. The thing is you should be aware about each step, because so if you have a design, so if you have a design in your mind, so your idea need to be converted into design. So you can use various kind of design software such as normal. We are using lot of new softwares, but normal AutoCAD software itself, you can use Fusion 360 and normal design software itself enough to create your designs. Then after creating your design, the design should be sliced into G codes. The machine cannot read the design directly. But nowadays, some printers, I have already told in a brand printer, they are nowadays they directly design. They are reading the design directly. So there is, but you need to slice the design into G codes using using some kind of slicers. So Orca slicers, ORC. Orca slicer is one of the commercial slicer. You can use all kind of 3D printers, and also Cura is one of the basic slicing software you are using for basic printers like. Creality and some other machines, you can use Cura. So once your design is ready, you need to slice the component and you need to convert it into G codes. After converting your G codes, you need to put it into the design into the 3D printer. Once you put the design into the 3D printer, the printer can print the design. After printing, you need to remove the part and you need to check with the quality aspects. With the different aspects, such as the part can be printed as per the design module. After checking with the design, you can put it into the customer. This is the simplest steps involved in 3D printing process. But the thing, so in each steps you can learn something. If you are good in design, each steps you have different kind of knowledges you can export from the 3D printing process. So from the first step you can get the idea about design engineer. Then you have to nowadays one slicing codes instead of G codes. Nowadays they have developed a code called a T code. Using T codes, the printer itself automatically, if you have any failure in the portion, printer itself automatically recognize those things and it will cover up those things. This is one of the advancement in slicing program. Nowadays they are using AI for slicing. Which portion you need more material, which portion we don't need to fill in the material. Like that, they are developing a lot using AI technologies. Then materials perspective. In 3D, during printing process, you have knowledges on materials as well as printing. So if you get the skill about materials, now materials engineers knowledge, entrepreneur knowledge, everything you have get it into the 3D printing during printing itself. Because there only you will know which kind of materials you are going to put for. If you are going to fabricate one kind of very complex profile, which process you are going to select. If you are going to do FDM or SLA, which process it will be suitable. Everything you will get a knowledge during the 3D printing process only. So then after printing the component, you will go the secondary process after finishing the part, surface roughness was high when you are using FDM process. You need another the secondary pre-processing steps are required. So that time you will get some kind of quality assurance and quality inspector skills in this portion. So then if you are selling the product into the market, you will get a marketing analyst as well as entrepreneur skill at this stage. So these are the process of 3D printing. So in all kind of 3D printer, there are three main components are there. One is fixed frame, then printing head, another one is print bed. These are the main component in all kind of 3D printers. But the thing is, the frames are fixed. Why it was fixed? It is a 3-axis printer. If you are going with a 4-axis now, the frames will not be fixed. So this is a fixed frame because they want to move in 3 axis. So they need fixed frame, then printing head. This instead of printing head, if you change with some this one which is related to filament based one. Instead of this one, if you are connecting with pneumatic based one, this would be going into direct ink writing method. Like that, these are then print bed where the material will be fabricated. The place where the material get be fabricated, which is called print bed. These are the main component when you are fabricating the 3D printer. Inside the extrusion head, there is based upon the technology, which technology you are going to use, the extrusion head will be varied. So, but the other processes are same. So during triple based printing process, there are some kind of defects which can occur. One which is called warpage, another one is which is called warpage, another one is I will tell you those things in the upcoming slides. I will show you with the images. Okay, the first one, the main one, which is the warpage, which will be eliminated by using large flat areas as well as sharpeners with the different material, which can be eliminated. Because if you are printing with the PLA, if you print the support with the, or a raft with the PED, it will eliminate this kind of warpage. So these are the some kind of defects which are occurred during FDM process. So coming to applications in healthcare. So the main application used in healthcare application is making implants. Implants is the one of the most important application in healthcare using additive manufacturing process, because each implant which is different when compared to the other implants. We call it as patient specific implants, because each patient the implant should be different, so we call it as patient specific implant, which is called as PSI. So then surgical instrument, nowadays they are using surgical instrument for each surgery. They will use a single surgical instrument, and they will discard it after the surgery. So complexity, based on the complexity of the surgery, the surgical instruments also developed using 3D printing technology. Then prosthetics and orthotics. Then medical models. Medical models are mostly used for surgical planning as well as education for the medical students. So these are the applications in healthcare. I will discuss those things elaborately in the coming slides. So first one is prosthetics and orthotics. Prosthetics, which the first one which is called prosthetics, the second one which is called insoles. So the people which are feeling severe knee issues as well as bone issues, they will use insoles uh, inside the shoes. Okay, this kind of insoles which are having their porous structure, we call it as lattice structure. Lattice structure, which is nothing but a repeated array of unit cell, we call it as lattice structure. The unit cell should be planar or TPMS. Yeah, in more kind of other kind of structures are available. So in these things, you can see there are the blue color as well as rose color prosthetics. They are using planar based. This is a hole based, just a hole. Why they are added these kind of holes? No? To reduce the weight as well as the air movement between these zones. In olden days, they have used in the slide A, you can see they have used the conventional method. We call it as Maukut. Conventional method, they have used some kind of plaster of Paris, clays, everything they have mixed with some kind of cotton bandages. First, they will cover up with cotton bandages. Then they will apply the paste like this kind of plaster of Paris as well as clays. The problem during using these kind of things, the air passage into these portions are very difficult. Adjustment when you are using these kind of things, now you don't need to take bath for 3 to 4 days, because you don't want to put water inside those places. When you are so for upgradation, they are using this kind of prosthetics. But the problem during this kind of prosthetics, now initial days they are not giving these kind of holes. They are putting full kind of plastic sheets kind of stuffs. Nowadays they are doing lot of research, and they have customizable prosthetic and orthotics using various kind of softwares. The simplest I will share you this what is the process involved in designing these kind of prosthetics and orthotics. When you have a bone fracture, the people will put it into this place. They don't need a CT scan. When you want to make a implant, they need a CT scan. Yes. Okay, when you are making implants, you need a CT scan. But when you are fabricating these kind of prosthetics, you just need a external scanner. Okay, just you need to scan the hand, and you can get the external outer body of the hand. Then after getting the scan data, you can put it in the software called Freeform. Geomagic Freeform. You can use this kind of software, and you can generate your clay body. After creating your clay body, the clay body can be converted into the design file using the same software. After making these kind of models, then we will put it into the some kind of peculiar software. We call it as NTOP, Grasshopper, and we are using a lot of softwares for making lattice structure embedding these kind of prosthetics. So after putting these structures, we will put it these kind of things into printer, and we will print the samples. So this is the simplest method for making prosthetics and orthotics. Then coming to insoles, when you are making insoles now, people will have a pain in the knees. They will fabricate insoles and they will put it in the shoes. This insole can be tested using force plate sensor. After fabricating these kind of insoles, the first one, red color, which is the insole which are not having the lattice structure. But the thing is, here we have given with a very flexible material which is called polyurethane, the material which are having good uh, insole capability, because the flexibility was good. But the problem during these kind of things are, if you want to reduce the weight, you need to go for this kind of structure. When you are seeing the sports shoes nowadays, they are having lot of holes in the bottom, which is called as cushioning effect. They are adding these kind of holes. But apart from cushioning effect, the flexibility, from the mechanical and engineering perspective, if the material which are having higher stress as well as higher strain, and the material will be good. So the material which has a higher strain rate, these kind of if you are incorporating this kind of lattice structure, the strain rate will be good. So the material, the flexibility will be high with the same strength. Then surgical instrument also, this is one of the equipment which are there, mostly they are using for the minimal invasive surgeries. So these kind of things, they, instead of using these kind of metal tools, they are using this kind of polymer based cutting tool. In the edges only they will use metals, so the cost of the cutting tool was reduced instead of using this kind of metallic tools. And also the problem during these kind of some kind of metals which has a corrosion resistance, not having corrosion resistance, instead of so if you are going with the stainless steel with the high corrosion resistant material, the cost was high. Instead of that, you can use this kind of material. Once you finish your surgery, you can easily dispose of this kind of surgical instrument. So these are the advantages of these are the applications in surgical instrument. Coming to implants. So implants, there are a lot of applications are there. In each application, in medical application, there are some kind of applications are there. In dental application, there are a lot of application. In physiotherapy, they are using a lot of applications related to implant. Mostly the implants, they are using two main zones. One is medical, another one is dental. The first one, which is in medical, craniofacial surgery. Which one? Which is the topmost one, which is the cranioplates. Then the second, this one is the spinal fusion cage. This one, which is a titanium screws. These are the bone plates, bone screws. Another one, which is so these are the main parts which they are using for the this one, intervertebral fusion cage. So these are the application. Most of the application they use this one, which is called as bone fixation screws in the with the bone plate. So these are the main application they will use for implants, because each application the implants will be different in sizes, and also the dimension also vary based upon the patient, based on the patient or surgery. If you have a fracture, based on the fracture, when considering this kind of spinal fusion cage, based upon the accident, if you have a head injury, you need to put the cranial plates in the head. Based upon the size of the defect, we should plan and make our own cranial plates. So this and all can be easily done by using 3D printing technology. Then medical models. Nowadays, they are mostly using medical models using 3D printing technology. What is the advantages of medical models using 3D printing technology? Exactly, we can mimic the organs using 3D printing technology. How I can tell you now, if you are printing a skin, the skin texture and color as well as feel, everything we can give as per the skin texture. If you are fabricating one organ, like one lungs, using 3D printing technology, you can develop the lungs, the same skin texture, consistency, color, everything we can make. But the thing is, you can't put it into the human body by using polyjet technology. The problem is, this kind of material will not fit into the does not accept the materials with the human things. But if you are fabricating the same material using bioprinting technology, you can fit it into the human body. So why this kind of technology is needed now? They will mostly use for pre-surgical studies as well as student training purposes. So if you want to train a student, mostly they will use cadaver, which is a dead body. They will use to train the students. But the thing is, if you have in most of the private institutions, they are having more than every batches they will have 200 students. So within they will have 2 to 3 bodies. But nowadays they are giving each 3 students, they will give the one organ and they will give to do the pre-surgical studies kind of application they are doing. So these are the applications of polyjet technology. So coming to medical 3D printing, which is nothing but when you are fabricating medical application products using 3D printing technologies, we call it as medical 3D printing. Not only medical models, medical applications such as implant, everything which comes under medical, we call it as medical 3D printing. Mostly we are cover up medical devices, pre-surgical studies, R&D, as well as medical education. These are the main application that the medical 3D printing evolves. The global market for 3D printing is planned around 1 billion USD in 2026, but in 2024 itself, the global market was crossed 1 billion USD. So this is a major breakthrough in medical 3D printing. So wherever you can use these kind of medical 3D printing. First one is cadaver. In cadaver, you can replace the entire organs using medical 3D printing. In this thing, you can develop, you can use polyjet technology for fabricating these cadaver models. Then pre-surgical models, they are also polyjet technology. Nowadays, they are using FDM also. I have already told you that nowadays they are developing a multi-jet process, dual nozzle, 3 to 4 nozzle. Prusa XL is one of the FDM based printer. They are using 5 different nozzles. So you can mix it with multiple materials with different, if you're selecting polyurethane material with the lowest shore hardness, and you can combine with the PLA with this hardness, you can make some kind of surgical models, pre-surgical models using F process itself. But you can't match exactly with the same as well as the human organs, but you can match somewhat. Then coming to simulation models, then organ development using bioprinting technology, then if implants using DMLS as well as triple F. And when we are developing compound using peak material, you can use triple F technology. When you are fabricating metal implants such as cobalt chromium as well as titanium, you can use DMLS method, direct metal laser sintering method. Okay. So what is the need of pre-surgical studies? When you are fabricating a tire in the car industry, if you are manufacturing a car tire, you need simulation. If you're a mechanical engineer, you know about the mechanical simulation. So ANSYS kind of stuff, so you will do the simulation. Similar to that, when in the healthcare application, the people when they are going with a complex surgery, they also need some kind of pre-surgical studies, because olden days they will check with the CT or MRI data. In the CT and MRI data, they will see only the in the pictorial form, they will see what happening inside, what is happening, the veins are touching or not. If why I am telling those things now? Recently, not recently, 1 year before, we have done one case study which is related to the patient which they came with liver, not kidney tumor. The respective surgeon gave that data of that MRI data of the patient, and we have tested with that MRI data. Initially, we have considered that one side of the kidney was with the tumor, but after examining with our softwares, pre-surgical process, we find out that both the sides the kidney has a tumor. So they have not given the surgery. They are not going to the surgery. They will go with the prescription based treatment. So these are the things now, advancement nowadays they are going on. So these are the these are the things nowadays they are going for pre-surgical studies. So what are the technology they are involved in medical 3D printing is pre-surgical cast development as well as implant development using triple F technology, then dental implants and dentures and crowns using SLA methods, then various metal implants for spinal and craniofacial surgeries using DMLS method, pre-surgical models and the cadaver development using digital anatomical printing, but it was very costly. Then bioprinting for organ transplantation and organ development. This also very costly. The DAB as well as bioprinting are very, very costly when compared to other 3 techniques. But these are evolving techniques. DAB as well as bioprinting are evolving, and bioprinting is purely dependent on the materials. and how you are developing these kind of things. Another, apart from these things, in triple F method, you can fabricate your own prescription using we call it as pharmaceutical in industry. It was very much nowadays. It was very good. I will show you those things in the upcoming slides with a detailed explanation. Okay. So what are the main materials they are used in biomedical additive manufacturing, which is PLA, PCL, which are the most used biopolymer, which are easily biodegradable. Then hydroxyapatite. For in ceramic, they will use hydroxyapatite along with the beta tricalcium phosphate, because bone is one of the material which is the combination of hydroxyapatite with beta tricalcium phosphate, which is a combination of two materials. We can make some kind of ceramic models, bone autographs or allografts, both the things we can develop using ceramic materials. Then metals, titanium and cobalt, chromium, these are the main materials, because these are does not produce this will not this was very good in biologically inert as well as biologically fitted to the human body. I will tell these things in detail about in the coming slide, because the stress shielding was the main problem during the development of titanium, cobalt, chromium as well as PEEK materials. How these kind of things can be avoided by using lattice structure, everything I will explain in the coming slides. Then bioinks, when you are seeding some kind of cells, which organs you are going to develop. The cells can be taken from that organ, and they are mixed with some kind of biopolymers, because the cells to be grown in a certain environment, so that needs some kind of biomaterial. So you can mix some kind of bio inks, which is biomaterials, with the cells. We can see that certain organ, we call it as bio ink. After growing these kind of bio ink, then we will put it into the printer, based upon the respective shape and size, we can print it. So this is the most of the material which are used in biomedical application. Apart from that, one main material we call it as PLDLA, and some other PMMA. These are some of the material which are mostly used for developing autograft and as well as allografts. So coming to so here from this slide, I will mostly cover up with the case studies which I have done during the past 4 years. So I will come up with the case studies. So first one, which is a polymer based implant, which is the PEEK implant. So in this study, we have developed a lattice based implant. In this work, we have taken 3 lattice structures. One is gyroid, another one is diamond, another one is primitive. These are the TPMS based lattice structure, which is a triply periodic minimal surfaces, which has higher surface area when compared to the other kind of structure. Why we are involving this kind of lattice structure now? When you are increasing the surface area of the if you are taking the cube, so for example 25 mm cube, so when you have taken 25 mm cube and you are making implant now, the surface area was very less. Why you need to increase the surface area now? If you increase the surface area, the interaction of blood as well as cells inside the human body was higher. So the cell regeneration was good when you are increasing the contact surface area. So this is the important point when you are fabricating implants. So if you are using this kind of lattice structure, why this importing this kind of lattice structure? The main problem during fabricating these kind of implants, stress shielding effect. So when you are making an implant with a metal or a polymer, the property of the implant should be matchable with the bone. So if it is a cortical or a trabecular bone, the property should be matchable. Now the material will not be failure, or if the implant should not be failed. So if you are putting this kind of material now in the future days, there will be a stress shielding effect. Stress shielding effect, which is nothing but the property mismatch between the implant material with the bone material. This will lead to generation of loosening of the screws, or else removal of implants, or failure of the implant. So the stress shielding effect should be avoided by using various kind of grading strategies, because when you are using fully with the gyroid, the sample which are having lowest strength and lowest highest highest stress and the lowest if you are using fully gyroid structure, the stress will be less and the strain will be high. So like that, all the lattice structure also behave the same pattern. So we have varied with different kind of gradient strategies such as uniform. The next one is functional grading with three different grading strategies we have followed. One is relative density, another one is cell size grading, the final one is combining cell size as well as relative density. We have used three different software to grading these kind of things. The first one is topology, then we have used Rhino. So combining both the software, we have developed these kind of models. So we have write our own code using MATLAB. After that, we have developed these kind of models. So after fabricating, we have tested. The results was very, very acceptable because our current work which has high strength and also acceptable strain rate when compared to the fully solid peak material. So the trapecular bone strength value will be less. Our values are comparatively high, but when you are compared with the cortical bones, the value was acceptable range. So if you make some changes like if you vary the printing parameters, you can adjust the compressive strength and match with the trapecular bone. This is the output which we have obtained from that the research work. Coming to the metal, in this case study, we have developed a cranial plate using people are doing a lot of optimization kind of work using various kind of printing parameters. But we have opted a method called design parameters. This is a planar based lattice structure. Instead of planar based lattice structure with the normal printing parameters, we have taken various kind of design parameters such as cell size, queuing angle, wall thickness, and orientation. Everything we have taken and we have considered with different levels, and optimal. We have developed optimal condition with respect to PMMA bone plate. Metaacrylate, it's a polymer. So initially we have developed everything using this PMMA polymer. PMMA is also one of the polymer mostly used for implantable material. After making those things, we will implement these things with the patient-specific implants such as cranial plate, and we have put it in the patient body also because at the time we have developed with the circular hole. After certain studies, we have developed these things and we have put it in the patient body, and the implant was remarkably worked well when compared to the normal hole. Then clay printing, which is not a clay printing, which is a ceramic printing. In this method, we have used HNT, which is a external nanotubes, and as well as PEG, polyethylene glycol, SS. The PEG, which is a material which are mostly used to as a for matching the viscosity of the material. We have added PEG because the main parameters you should consider making clay bioceramic inks is the material viscosity should be acceptable range, because the material based upon the viscosity, the material will comes out from the nozzle. So this can be measured before printing a sample. So this can be measured on per viscometer. So after making with different weight percentage of HNT, the 67 weight percentage shows better extrudability, which is nothing but the material which comes out in a uniform manner, which is called extrudability. So the material with 67 weight percentage which shows better extrudability. So this combination we have developed, we have optimized, and we have used with different kind of nozzles. We have used 24G, 22G, 20G, which is nothing but gauge length. When you are going for a when you going to a medical practitioner, they will put a injection. So the injection with the different nozzles, okay, similar to that in this kind of paste printing. So they are using 24 gauge length nozzle, 22 gauge length nozzle, and 20 gauge length nozzle, which is nothing but 0.3 mm, 0.4 mm, 0.6 mm. So using this nozzle gap, you can't adjust the layer height with the slicing software itself. You need to adjust the what type of nozzle you are going to put. That then using that nozzle only you can export it. So from that it is concluded that the sample with the 22 gauge length nozzle shows better results when compared to 24 gauge length, and the strength also good, and the samples which are after solidification also the sample dimension was good when compared to 24 gauge length. So this is the outcome of this work. Coming to biopolymer, in this work we have taken two different kind of polymer. One is alginate, another one is gelatin. Sodium alginate, which is the one of the polymer which they are using in gelatin, used in most of the biopolymer fabrication for wound healing application. Gelatin, there are various kind of gelatins are available. Food grade gelatins are available. Another, which is this material which are mostly used for making bandages. These kind of materials they are using for wound healing application. So we will mix the drug along with these kind of polymer and we'll make our own shapes and we will print it. And we are using cross-linker here. We have used cross-linker to cure the material. After cross-linking, we have tested these samples with various kind of studies, and we have used. It is in the stages of converting into the real-time application. So coming to composite 3D printing, composite 3D printing has a lot of scope for fabricating. What is the need of composite 3D printing is when you are making some kind of particular material, when you want to make some kind of enhanced properties. When you have a polymer, the polymer which has a brittle in nature. Normally, I will tell about the polymer, PLA. Okay, PLA which has brittle in nature. Okay, so in order to reduce the brittleness and you want to increase the strength, you need to add some kind of reinforcement into you. So you want to enhance the base polymer property, you are going for mixing with another material, we call it as composite. So, so in order to increase the strength to weight ratio and other kind of mechanical other aspect properties, you need to add this kind of some other kind of materials. Coming to biomedical application, why you need composites now? If you want to improve the some kind of bioactivities, so you want to increase the antibacterial properties. The material should be resistant to bacteria. So you need to add some kind of antibacterial agents to the polymer and you can fabricate your material and you can develop those components which is called as biocomposite. So like that we can do lot of things using composite 3D printing. There are a lot of approaches are there. One is particle based approach, another one is pellet based, another one is wire based approach. One of the best printer for making composite printer for is onyx printer, which they will use carbon fibers along with the nylon. They will mix together and they will make onyx composites. So coming to research scope in polymer 3D printing and filament extrusion. So most of them are faculty, I think. So everyone want to publish some papers. Apart from your academic journey, you need to publish some papers. So how this kind of 3D printing can be useful for your research publications now, I will tell you. So from the research, not from the research perspective, I am telling about the publication perspective. I am telling. So if you want to make some papers or research article from your side now, you need to select some kind of reinforcement. Normally in composite application, people will select n number of reinforcement without knowing why they are going to adding those kind of reinforcement. But from the thing is from the reality, they need to publish some papers. Okay, so like that, I am telling you, you can select any reinforcement. Okay, you need to select polymer also. Based upon the type of polymer, the printing extrusion parameter will be varied. So first you will select some kind of polymers, then you can select reinforcement, which may be an organic or inorganic reinforcement. Nowadays, they are most focused towards sustainable development goals, SDG goals. So if you are concentrating towards recyclable materials, now that would be benefit towards sustainable development. So you can select based material, recycled material. So in my research, I have taken lot of material related to marine derived materials. Why? Because I have taken marine derived materials like crab shell, egg shell, seashell kind of things. I have selected a lot. Why? Because these are the rich source of calcium carbonate. Because we are most focusing toward developing bone ceramics, bone composite, bone plates. So we are much focusing towards bone materials. So we have selected these kind of materials and we have synthesized hydroxyapatite from these kind of shells, and we have put this material along with the various kind of polymers, and we are extruding the filaments. After putting into the filament extrusion process, After extruding the filaments, you can characterize the filament. The filament property itself you can publish as a short communication paper. So like melt flow index, filament strength, filament diameter, surface roughness. After printing into a certain layer, after printing itself, you can make. Recently, I saw one of the video about bamboo printer. They have upgrade card with different kind of layer resolution. 0.1 mm, 0.2 mm, 0.3 mm, like that they are printing. What about the extrusion rate? It is coming or not? It's a good manner. If the extrusion rate was good or not, like that they are measuring. So you can measure in some other parameter also. You can characterize the extruded filaments. You can publish as a short communication. Further also, you can increase some more parameter and you can publish its full length article also. Based upon what are the parameters you are selecting, how many combinations you are selecting, based upon that you can publish as a short communication or a full length article. Then during extrusion process itself, you can extrude the filament with various type of parameter, and you can use AI or machine learning methods in this step, and you can publish as a full length article. This is also one of the main area. You can measure the hardness, or else you can measure the filament diameter or filament strength. Any one of the parameter you can take, and you can use any kind of machine learning algorithm, and you can publish as a good article. So this area also you can publish on full length article. Then coming to printing process. In printing process, you know already know, people who are working on 3D printing, everyone knows that there are a lot of printing parameters are there. So you can optimize the printing parameter for the particular composite material you are developing. So this kind of material you can do the printing parametric study, and you can publish as that also in a good journal. Q2 or Q3 journal you can publish. But if you are characterizing all the mechanical as well as physical, thermal, dynamic, tribal, all the properties together, and you can publish a good Q1 journal with a good impact factor. So these are the publication scope in this area of composite 3D printing with respect to triple F. I am only discussing about fused filament fabrication only. Similar to fused granular fabrications are there, SLA there is there. Like that, there are a lot of 3D printing technologies are there. I am only discussed about to you with the triple F process only. You can do lot of research in this step itself. Okay. So what are the difficulties I have faced during the initial stages? When so 2020 I have started this area. I have learned lot during the. I have fabricated one full extruder with my experience. Okay, initially I have done with the one benchtop type extruder, but the thing is we have faced a lot of problem because adding beyond 10% of silicon. I have initially I have started with silicon particles. So beyond 10% of the silicon particle, we will not get a full component, because during that extrusion process, the motor RPM is not enough to pull the material out from the nozzle, and also the particle concentration of 10%, 15%, the particle size is also bigger. So it is not able to extrude the materials in a good form. But after that, we have make our own machine, and we have extruded filaments in a good way. And nowadays we are extruding 20 to 30% of the concentration of the reinforcement particle. But the problem is you need to optimize lot of parameters during extrusion process. Otherwise, you will lead lot of problems like diameter reduction during extrusion, over diameter when you are not maintaining the temperature properly. The over diameter will occur when you are the temperature is too high. Now shear thinning will occur when the particle sizes are big, or your particle sizes particle ratio was high. Now nozzle clogging will occur. So these are the problems when we will face when during the extrusion process. You need to optimize all the steps before going into the extrusion process. Then during 3D printing, you will face a lot of difficulties. I have already told you warpage defect. So this can be avoided with the raft support. Then you need the material which you are going with a higher composition of wood-based particle. The bed adhesion was not good. So you need to put some kind of adhesives in the print bed surface to make the surface to be printed properly. If the material is very brittle, or it will absorb more moisture or humidity, the filament will be breakage during the extrusion process itself. So this can be avoided by adding some kind of plasticizer, or the material should be put it in the humidifier before put it into the printer. Okay, so case studies related to composite 3D printing. This is the first work which I have done. I have used crab shell and I have extruded some kind of I have synthesized the hydroxyapatite from the crab shell and I have extruded composite filaments and I have tested with the basic parameters and I have published in a Materials Letters Journal. From the results, it is concluded that 8% of the composite concentration shows better results. Adding beyond that, the strength was reduced, but the problem during the extrusion was the adding more concentration of particle leads to increasing the surface roughness. This is the only the negative thing, but the increasing the surface roughness has advantages in bio application because the higher surface roughness makes more active areas. It will leads to formation of higher surface area. So similar to that, we have varied with various printing extrusion parameters and we have extruded with the optimal combination and we have tested with the combinations and the performance was good when compared to the PLA polymer. And the samples which are shown some negatives, the contact angle itself shows that contact angle of PLA was higher when compared to the contact angle of crab shell PLA was low. This is the indication the surface roughness was high. Now, automatically the surface area high. The surface area is high means the higher concentration of water absorbent tendency also improve. So this is the simplest thing. So this is the work which we have recently done. This is the pellet-based 3D printing technology where we have used pellets and particle when we are mixed together and we are making solder method. Solder solution casting method to make the composite pellets. After making the composite pellets, we have put it into the barrel and we have printed with the various sample with the respective ASTM standard. We have fabricated various components, various samples, and we have tested with the samples. So we have added bioglass as a reinforcement because we are this application we are going to make for the not for wound healing. We are going to focusing towards implants. So the result was very good. That adding bioglass, the hardness was improved. The strength was good for the 3% composition, and also the contact angle was decreased due to the added particle, which has made more layer gaps. This layer gaps leads to reduction in the contact angle. So coming to application, there are various kind of applications I have already told. Among that, in healthcare application, this is the dental-based application. They are using various kind of screws and nets for the tooth implants when they are putting into the human body. Then tooth is one of the aligners. They are mostly used for making the tooth align properly. So denture, mostly they are going to fit the dentures. If you are fabricating these kind of crowns, now they are going to check with the fits. They are using dentures. The crowns also they are using with the bone. Ceramic based resins are available nowadays with the SLA process. So they are using there also. I have already told that the USA based scientists they have developed in the Black Forest Medical Institute they have developed lung, bones as well as ear models using the human things and also some kind of implant models. In food packaging, they are also they are using 3D printing for making different grades of foods. They are mixing. They are taken fat, blood, muscle kind of cells, and they are mixed together and they are printing. So this is the area where the pharmaceutical industry. I have already told you that in future or not in future in current days they are using extrusion based capsules they are making based upon the drug you are going to take. If you want to take a drug with respect to if you have a fever now they will give you one antibiotics, another one is normal like that you have different types of drugs are there. So currently they will give you given the tablet and you have taken one tablet this way like that. In future it will not like that. They will give you a single drug with a different composition based upon the age factor, based upon the seriousness of the issue. They will give with the compositional with like various drug composition. They will mix together and they will make a pellet. If you are seeing the doctor now, they will print immediately. They will print it and they will give it to you because these drugs are in the wire form. Once you will visit your doctor now, they will just given the prescription to the software now, they will give it as a tablet. Like that they are doing research nowadays. Okay, this is called as a personalized 3D printed medicines. We call it as. And also in drug delivery also, they are doing lot of things related to how they are the shell. If you are making a tube kind of prescription, you can see now drugs. So best if you put the tubes into the water now, it will be open up, because these are biopolymers. If you put water in the tube now, it will melt it off. Okay, so how fast it will react with the patient body, how that kind of, nowadays they are doing research on that also. Okay, so coming to pre-surgical model, there are simply there are three methods to fabricate the pre-surgical model. First one, which is you need CT or MRI data. After getting the CT and MRI data, you need to convert the CT and MRI data into CT and MRI data, which are digital data. So you need to convert the digital data into design data. So if you need to convert the digital data to design data, you need a particular software called, here we have used D2P software. Similar to D2P software, we have various kind of mimics, Dragonfly, a lot of softwares are there. So you need to use any one of the software, and you need to convert the design digital data into design data. After converting the design data, you need to put you need to segment which organ you need to develop. So if you want to segregate a bone, now you need a CT data. If you want to print any kind of soft tissue, now you need a MRI data. So based upon the data, you need to segment the organ using auto segmentation options are there, or manual segmentation options also there. Based upon the thing, you can segment the organ, and you can export the file in XML format. Then you can put it into the printer, and you can print the object. This is the simplest steps involved for the medical organ development. This is the simplest data which we have segmented the circle of release from the human brain from the MRI data, and we have printed well. So this is one of the pre-surgical models we have developed and we have printed. So they are doing surgery of the rental arteries. So the exact mimic of arteries consistency, these materials also behave. So these are photopolymers with respect to exact mimicking of that organ consistency. So these are some of the models. So this is one of my this is my CT data, and I have developed the model using the same softwares, and I have 3D printed my model. And if I have pre-processed well, it will be coming a good way. So these are some of the case studies. This one is first one, which is a surgical cast, the 3D printed surgical cast. The second one is a mandibular implant, is a metal one. Then this one is a commercialized implant, titanium implant. This one is some of the functional graded implants. So these are some of the examples for material 3D printing. These are the future of 3D printing. Nowadays, people are much more interested toward multi-material 3D printing, because single 3D printing, single material printing is very easy one. People are much more the need of multi-material 3D printing is shape recovery effect, like that. People need this kind of application. So transforming materials are the upcoming research area. You need to energy storage kind of things. Now you need multi-materials for developing this kind of things. They are mixing with hydrogel with normal polymer, and they develop some kind of self-transforming materials. Organ also I have explained a lot. So anyone who are interested to do some kind of collaborative research, now you can contact with us. So we are also supporting for filament extrusion, composite 3D printing, laser machining, as well as testing of various composites, and also bio studies, and also supporting for design and simulation also. So those who are really interested to do collaboration with us, you can contact us. Thank you.
Sir, so I posted some consolidated questions for you.
Yeah, sure.
Last box I posted the questions raised by the audience. So for
your
better purpose, I consolidated it and posted them. So apart from that, participants, do you have any questions you may ask after you get answer for these questions?
How does the particle size and surface treatment of natural fillers influence the mechanical? Yes. The first question, which is so there are a lot of chemical treatments are available nowadays. So the first, the comparatively, which kind of application you are targeting. If you are going for a There are a lot of processes are there. First one, which is called normal. If you are going for sodium hydroxide, which is an NaOH treatment, it will eliminate some kind of hemicellulose or other kind of stuffs. If you go for silane kind of stuff, now it will go suitable for inorganic materials. If you are using crab shell kind of stuff, now you will go for silane based method. So your question is how this treatment will impact the mechanical and thermal behavior. This is the simplest step. If you are going for chemical treatment, now it will remove the unwanted materials like pectin, wax, hemicellulose kind of component from the normal natural fillers. So it will increase the strength as well as mechanical property. As far as compared to thermal property, the unwanted material like wax, pectin are the thermal property reducing substance. If you remove those substance using thermal, NaOH treatment itself, it will improve. When you are going for crab shell, which is a hydroxyapatite, if you are using silane kind of treatment, which is a trivinyl ethoxysilane or some other silane compounds are there. If you're using this kind of silane component, now it will enhance the silane bond and it will enhance the strength as well as the thermal properties. How do multi-material composite produced via additive manufacturing perform compared to single material structure and biomedical applications? Yes, so if you are want to make a multi-material composite, nowadays there are two extrusion head printers are there. If you're using these kind of two different head printers, now you can easily print your component. So I will tell you some application now. I have already told you that bone as well as skins with a different texture as well as consistency. So if you are making these kind of things now for pre-surgical models, you need two different materials. So multi-material will be suitable for this kind of application. Okay. Among different 3D printing techniques, what are the critical factors that determine print resolution and part integrity for polymer composite? What are the critical factors that determine print resolution? So each printer, based upon the nozzle size, it decides the print resolution. If you're going for FDM, you can use 0.2 mm nozzle also. Nowadays they are available in market with 0.2. Normally they will give you 0.4 mm nozzle, 0.2 mm, 0.4 mm, 0.8 mm, or commercially 1.2 mm until 1.2 mm. The nozzle dimensions, the nozzles are available. If you use 1.2 mm now, the layer resolution will not be good. So if you use lesser nozzle size, the part size will be good. If you are using for polyjet now, the nozzle diameter is 0.5 digit 0 and 1. This is the layer resolution for polyjet. Okay. If you are going for bioprinting now, the nozzle should be selected based upon your requirement only. So based upon the selection of your nozzle size, the your print resolution should be made. Apart from that, after printing, you can use secondary process like sanding and other chemical vapor smoothing kind of steps you can use to improve the print resolution. So these are the some other things. What are the biggest research gap in polymer additive manufacturing that young researchers should focus on? There are a lot of research gaps are there because every day we are facing new issues. Okay. So the person who has asked this question, in person we can discuss a lot regarding these research gaps. Okay. How do different lattice geometries such as gyroid, honeycomb, hexagonal compare in terms of the strength to weight ratio and structural performance? Mostly we are comparing lattice structure with respect to stress shielding effects. We are comparing with the stress with the strain. Okay. So if you are adding in a conventional solid component, the strength was high when compared to the lattice to one. The lattice to one, which is a balance between strength as well as strain. It is a balance between strength as well as strain. The main purpose of adding lattice geometries in this kind of application is to improve the stress shielding effect. This is the main phenomena when we are using for healthcare application. How effective are machine learning models in predicting the mechanical behavior of 3D printed composite, and what are the current limitations? We are currently we are using 5 to 6 models. We are fabricating for analyzing the mechanical behavior of the 3D printed parts. The limitations are data sets. Normally, we are going to use mostly with 27 to 60 number of data sets. If you increase the data sets, now the machine, the developed model accuracy will be good. So the main limitation nowadays now we are facing is the data set only. If you increase the data set now, you can do lot of optimized models to generate your application. Okay. What are the property requirements for biodegradable implants? Mm, the the main thing, if you are making biodegradable implant, should be uh, application wise it will be differ which kind of application you are going to put it in. If you are going to uh, mostly implants, they won't go for biodegradable implants because uh, graft materials they will go for biodegradable one, because the bone which we are regrowth now, and that portion we will go for biodegradable things. But the fractured portion, the some bones which will not again regrowth, like, that portion you can't put it into biodegradable material. They will put with metals like peak or some other materials, or some kind of cobalt chromium or metal titanium kind of materials for implants. But most of the graft materials, which are the support materials, they will go with biodegradable materials like PLDLA, like that they will go. Okay. Which type of coating is preferable for composite coating, dip coating? Uh, this also for dip coating, we won't use for the 3D printed one. We won't use dip coating when we are put it into the human body, because if you use dip coating with the compatibility between the two material is not good now, it will peel out. Okay, so we are not using dip coating for the 3D printed composite till now. But I will check with this one, okay, because I am not sure with the dip coating, because I have not yet used dip coating. But mostly people will not use dip coating. I will check this one, okay.
Dear participants, do you have any questions? Dear participants, still you have any question means you may post here. Okay. I think the questions are all asked by answers are given by our given by our experts will be satisfied for you. So 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 the, we are coming at the end of the session. So on behalf of the organizers and all participants, I will take this opportunity to sincerely thank our esteemed resource person, Dr. Sabarinathan sir, for delivering such an insightful and engaging session today. Surely your expertise, valuable inputs, and practical perspectives have enriched our understanding and made this session more truthfully, sir. So we are grateful for your time and effort. You have dedicated to be with us for sharing your knowledge. So once again, I thank you, sir.
Okay.
So, dear participants, our next session will start within 5 minutes. So, our guest is also joined with us. So, by 7:35, we will start our next session.